So in this lesson, we're going to take a look at the different type of graphs that we've worked our way through, what their parent function is, and what their key attributes are. Okay, so in the first one, we have a linear function. The parent function is f of x equals x, or y equals x. Its shape is a non-vertical line, because if it's a vertical line, it is not a function. It generally has one x and y intercept, unless it's horizontal. Horizontal is still a function, similar to our step functions. And it has a constant rate of change. Okay, so in our second one, we can see that we have an absolute value function. And so the parent function is f of x equals the absolute value of x. It is a V shape. You have a vertex that is a maximum or minimum, depending upon which way it opens. Domain is all real numbers, and the range depends upon the vertex. There is a constant rate of change. However, one is positive, the other negative. May have 0, 1, or 2 x-intercepts and has 1 y-intercept. Okay, so that's our absolute value function. Next is our exponential function, where it's f of x equals a to the x power as the parent function. Its growth, if a is greater than 1, it is a decline. If a is greater than 0 and less than 1, our domain is all real numbers. Our range, it varies based upon a vertical shift. Okay, so in other words, if I move this up or down because I add some number to my function, then that'll change my range. It may have 0 or 1 x-intercept. There is 1 y-intercept, and it has a constant ratio, meaning I multiply by the same value each time. Okay, that's our geometric sequence concept. All right, next we see our quadratic, with our parent function being f of x equals x squared. So we have the same thing. It is a vertex, and it's a maximum or min based on A. Okay, so remember, if A is positive, it opens up, then it's a minimum. If A is negative, it opens down, that's a maximum. Okay, rate of change varies over each interval. Okay, so there's not a constant rate. We have symmetry. Remember, when we divide this in half with our axis of symmetry, we have symmetrical sides. May have 0, 1, or 2 x-intercepts. And we have 1 y-intercept, which is our value of c. Okay. Continuing on. This is our square root function. So our function is f of x equals the square root of x. It is a reflection of part of the parent quadratic function. Okay. So it was that reflection over the line y equals x can be 0 or 1 x and y intercept. There is an endpoint. In other words, you'll see on your calculator that at certain x values, you will have error messages for the y corresponding y values, which tells us that our domain has restrictions based upon the particular, sorry about that. So it's based upon the particular function. So if it's the base case, you'll see that x, the domain is 0, x is greater than or equal to 0. I can't have negatives. But if I had some values under that radical sign, then that changes what can happen there. Okay? Next is our cubic function, where it's f of x equals x cubed. It's a reflection of the cube root function over the line y equals x, similar to what we said above. Our domain and range are all real numbers, and there is one x and y intercept. Okay, now we're going through this mainly as a refresher, not expecting you to memorize all of this stuff, but at least understand the key attributes that we're talking about. And next we have our cube root function, which we were referring to before. So f of x equals the cube root of x. Our domain and range is all real numbers. Since it's a cube root, we can have negatives under there. And we have one x and y intercept. And then finally, we have what is called our piecewise linear function. Helps to spell it correctly. And so the way we would write that is f of x is for some equation, that linear function, and then a second linear function. Okay? So shape is multiple linear sections with each section having a constant rate of change. Okay, so that's kind of our recap of the graphs of the different types of functions that we've seen.